we just dealt with this idea of a reference number, but now we're going to formalize it a little bit here, right? We just dealt with it when we were dealing with angles like negative pi over 4 and negative 5 pi over 6. So to find a terminal point in any quadrant, you really just need only to know what you might call in quotation marks the corresponding terminal point that's in the first quadrant. And that corresponding terminal point in the first quadrant, we're going to call the reference number. And really, this is no difference. It's just a little, different way of looking at it. This is no different than when we did in the last chapter, the reference angle, right? The only difference is we're thinking of it as a distance around the unit circle rather than an angle. But really, we can use these phrases interchangeably, reference angle and reference number. They're really the same thing for our purposes, right? It's just a little bit different in the way you're looking at it, right? One you're looking at an angle, one you're looking at it as a distance. So how do you find the reference number, which we're going to call T bar, right? Because remember before, when we were dealing with the angle, we called the reference angle theta bar. So now in our textbook, they're calling the reference number T bar, right? Which is basically the same as the theta bar. So how are we going to find it? The same way we found the um, reference angle, right? So when we're in the first quadrant, it's simple. T and T bar are the same. So for a first quadrant angle that's measured counterclockwise, right? So it's positive. T and T bar are the same. Now over here, when we're in the second quadrant, what do? Well, we rotate T, right? And then T bar, which is our reference angle, remember, is this little angle that goes from the terminal point down to the x-axis. And do you remember how we got that? Well, T bar in this case was the same as half the circle, which was pi, minus the original angle, which was T. So T bar would have been pi minus T. And then when we're in the third quadrant, right, there's your T all the way around there. T bar is that angle that goes from the terminal point up to the x-axis. So in this case, our T bar was really T minus pi. And then in the fourth quadrant, right, there's our T. So our T bar is this little angle that's remaining to get from the terminal point up to the x-axis. So it's really the whole circle, which is 2 pi, minus the angle, which is T. So in this case, T bar is going to be 2 pi minus T. All right. So those are just little tricks that you can use if you want to find what the reference angle is. But there's even an easier trick, which we'll talk about later. So they just clarify here that when you're in the first and the fourth quadrant, you're actually moving to the positive x-axis, right, to find the reference number. And when T is in the second or third quadrant, you're actually going to the negative x-axis. That's not a huge deal, though. I mean, as long as you just remember that you're always going to the x-axis. Sometimes you're going to the positive x-axis. Sometimes you're going to the negative x-axis. Not a big deal. All right. So to find the reference number for these various angles, we can just use the rule that we developed before, right, if we want. So 5 pi over 6, 5 pi over 6 is in the second quadrant. So how would we get that reference number? We would just do T bar is pi minus 5 pi over 6, which is going to be pi over 6. So that's our little angle there. That's pi over 6. That's our reference number. Right. And again, I'm using reference number and reference angle interchangeably. Sometimes I'll say reference number, sometimes I'll say reference angle. But as long as we accept that an angle can be a distance, it's not a big deal. Okay, so there's our reference angle for 5 pi over 6. It's pi over 6. So for 7 pi over 4, there's your 7 pi over 4. It's in the fourth quadrant. Remember, in the fourth quadrant, we would do, to find the T bar, 2 pi minus the angle, right? So that's 8 pi over 4 minus 7 pi over 4. So we end up with pi over 4. So our reference angle for 7 pi over 4 is pi over 4, again, which is this angle right here. And then for negative 2 pi over 3, well, in this case, it's a little bit different because this is a negative angle. So negative 2 pi over 3. This one is a little bit different. So what we can do if we want, I mean, this probably isn't the easiest way to do it, but what we can do is we can turn it into a positive angle. So negative 2 pi over 3, if we think of it as being the positive value, it would have actually been negative 2 pi over 3 plus 2 pi. So it's actually coterminal with 4 pi over 3, right? Because if we do negative 2 pi over 3 plus 2 pi, that becomes 4 pi over 3. And now we're back to where we have a positive angle that's in the third quadrant. So how do we find our t bar in the third quadrant? What we had done is we had done the angle minus pi, which in this case is 4 pi over 3 minus pi, which is going to be pi over 3, right? So in this case, our reference angle is pi over 3. And then in the last case, we don't have an angle in terms of pi, right? We don't have a number in terms of pi. T is 5.80. So realize that that's in the fourth quadrant, all right? So when we're in the fourth quadrant, remember our rule was that T bar was just going to be 2 pi minus the angle. So it's 2 pi minus 5.80, and 2 pi is approximately 6.28, right? So we're really doing like 6.28 minus 5.80, and you get approximately 0.48. Right? So it's not exact, it's just an approximation here because we're just approximating pi. The exact value is actually 2 pi minus 5.80, but if we approximate it, it's 0.48. Okay, so one of the things that you should get out of this is the fact that whenever our angle had a denominator of 6, we end up with a reference angle of pi over 6. Whenever our angle has a denominator of 4, our reference angle is going to always end up being pi over 4. Whenever our angle has a denominator of 3, our reference angle is always going to end up being pi over 3. So that's just like a little trick to remember it. I mean, you should realize the method you have to use to find the reference angle formally, right? By doing the pi minus the angle, or the 2 pi minus the angle, or the angle minus pi, or the 2 pi minus the angle. But it's nice to be able to remember that little trick, right? If the denominator is 6, then it's going to be pi over 6 reference angle. Denominator is 4, it's going to be pi over 4 reference angle. Denominator is 3, it's going to be a pi over 3 reference angle. So that's just a little shortcut that you could use. Okay, so why don't we formalize what we just did here, right? What we just did here is we found reference numbers, right? So now we're going to want to use those reference numbers to find terminal points that lie on the unit circle. So to find the terminal point determined by any value of t, what are you going to do? You're first going to find the reference number, right, which we had called t bar, right? Or I had called it reference angle. I'm using these phrases reference angle and reference number interchangeably, so please understand that they're the same thing for our purposes. I'm just thinking of an angle as it can also mean a distance, right? Because when they say reference number, they really think of t as being a distance, right? But we can think of an angle as being a distance. So the reference number you find first, then you find the terminal point of that reference number, right? And then you just use the quadrant that it's in to determine the signs, right? So you're going to have the same absolute value of A and B, right? Except if you're in the second quadrant, well, A is going to be negative, B is going to be positive. If you're in the third quadrant, both A and B are going to be negative. If you're in the fourth quadrant, A is going to be positive and B is going to be negative, right? And that's just from your basic knowledge of the coordinate plane, right? In the first quadrant, both coordinates are positive. In the second quadrant, x is negative, y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive, y is negative. So you're just using that idea at the end once you determine what the terminal point of the reference angle was. Okay? So let's try a couple of these. So 5 pi over 6 first, right? So 5 pi over 6, if you remember our trick, we'll just use our trick here. I'm not going to go through the calculations. 5 pi over 6, the reference angle was pi over 6, right? Because remember we said if it has a denominator of 6, the reference angle is going to be pi over 6. So now we would go to our table that we had, right, that said pi over 6 corresponded to the point radical 3 over 2, 1 half. So we're dealing with the point radical 3 over 2, 1 half. But 5 pi over 6, if you remember, was in quadrant 2. And in quadrant 2, x is negative and y is positive, right? So what is our terminal point here? Our terminal point for A is actually going to be negative radical 3 over 2, positive 1 half. And then for 7 pi over 4, right, B, we knew that this has a denominator of 4. That means our t bar is going to be pi over 4. And the terminal point of pi over 4 was actually radical 2 over 2, radical 2 over 2. Remember? That was where they were equal at pi over 4, radical 2 over 2, radical 2 over 2. So we know that this is in quadrant, 7 pi over 4 is in quadrant 4. And in quadrant 4, x is positive, but y is negative. So our terminal point for 7 pi over 4 was going to be radical 2 over 2, negative radical 2 over 2. Right? So this is our solution here. For some reason, this highlighter is not being thick. So that's our terminal point for A, that's our terminal point for B, and then C, we just do a similar thing, and we realize, again, okay, you don't have to worry about this. T bar is pi over 3, because our angle has a denominator of 3. And at pi over 3, the point was actually the reverse of this. It wasn't radical 3 over 2, 1 half, it was 1 half radical 3 over 2. And again, you'll get good at this the more you do it, right? What was this? Pi over 3 we're doing? 1 half radical 3 over 2. Right? So now just realize, hey, negative 2 pi over 3 we had said was actually in quadrant 3. So in quadrant 3, both x and y are negative. So the terminal point of negative 2 pi over 3 is actually going to be negative 1 half, comma, negative radical 3 over 2. So there's your terminal point for negative 2 pi over 3. So not terrible stuff, right? Not too bad. And this is what we had been talking about before, right? So a lot of times what you might want to do is if they give you a t value that's like outside of the 0 to 2 pi range, it might be easier to first add or subtract 2 pi once or multiple times to get back to a number between 0 and 2 pi, and then find the reference number that way. That could be a little bit easier, right? So like 29 pi over 6, what they do is they think of 29 pi over 6 as 4 pi plus 5 pi over 6. So what they're really doing here is they're really saying, all right, well, how can I get 29 pi over 6 back between 0 and 2 pi? I would do 29 pi over 6 minus 4 pi, right? And 4 pi would actually be 24 pi over 6. So 29 pi minus 24 pi is going to be 5 pi over 6. So it's actually coterminal with 5 pi over 6. And then you know, just from basically what we did, t bar, since this has a denominator of 6, is going to be pi over 6. And realistically, in this case, we didn't even have to do that. We could have just looked at the denominator right from the beginning and said, all right, 29 pi over 6 has a denominator of 6. So the t bar is going to be pi over 6. Okay? So once we know that the t bar is pi over 6, then what we can just realize is, all right, well, 5 pi over 6 is in the second quadrant. So it's in Q2. And it has a reference number of pi over 6. So if we go back to our table at pi over 6, it's radical 3 over 2, 1 half. So we know this is going to be radical 3 over 2, comma 1 half. But we know that in the second quadrant, it's negative, positive. So our terminal point is going to be negative radical 3 over 2, 1 half. Okay, because it was a negative x and a positive y. So that would be our terminal point there. And then they just take you through it and they show you graphically, right, how you're wrapping around the circle a couple times before you arrive at the point. But it's still the same point, negative radical 3 over 2, 1 half.